So today we're going to be talking about how to control and isolate sound. And we pretty much know that it's kind of tricky because we're dealing with many different aspects. We're dealing with environment, with the different tools. So we're going to be covering all that information today on this course. We're going to be reviewing the needs for creating sound isolation spaces and how much sound isolation is needed depending on the different circumstances that we may have. We're also going to be reviewing the 3 different tools of sound isolation, which is mass, absorption, and mechanical isolation, and the role that each one of them play within your environment as well. We're going to be obviously reviewing the benefits of working together, each different trade, and collaborating to make sure that the end user or our client receives the expertise and the proper design for their space and to make it functional as well. I'm going to skip this. I mean, this is part of what I mentioned earlier. Like this is a CEU registered class for AIA and also for ASID. And then here you have the different information on the course. But again, we're going to be emailing that to you guys later. So,
okay, so we are still on course description, if that was what you're thinking.
Okay. You guys are seeing this? Learning objectives?
No, we're on course descriptions and we see your thumbnail view.
Okay.
Okay. ID CEC approved.
Is it maybe connection is kind of slow?
Jeff, I'm actually seeing course description. I'm seeing as she's changing on my side.
Oh, good. Okay.
I see ID CEC approved now.
Okay. Are you guys seeing the learning?
I'm back to course description. Now IDC CEC approved.
Okay.
What should we be seeing, Vanessa?
It should be saying learning objectives at this point.
Okay, I see that. Does everybody else see learning objectives?
I see learning objectives too.
Yeah.
Okay, let's go with that. Looks like it's working.
Okay, good deal. So we're gonna again just define the different and the importance of controlling sound. We're gonna define how much sound isolation is requiring for the different circumstances. And like I mentioned earlier, we're gonna review the 3 main tools that are gonna be important for the sound isolation, which is the mass, absorption, and mechanical isolation, and the role that each one of them play. And also we're gonna be talking about the different design considerations related to the construction and the different specialty rooms that we may have. I'm switching this different slide right here. Don't get scared when you first read the indoor shooting range, but you know, like it's one of those that it's funny when this course was written and I was learning about it. There's a lot of houses that actually build this kind of settings in their houses. So the reason why this slide is here is because, you know, we usually hear sound isolation in home theaters or multimedia rooms, but there's many other reasons why people or companies might want to do the proper sound isolation in their buildings or even residences. So, you know, like in one of the examples is the indoor shooting range. There's a lot of people in the Midwest, and there was a house specifically in Denver that has separate shooting ranges. You might also have a car lift garage in your residence or a woodworking shop in, like I mentioned before, the typical home theater or multimedia room, and maybe like an office private space that you want to make sure that is completely isolated from sound. So we also have, you know, like the different spaces in commercial applications, you know, that are becoming very popular. It's this industrial space is being used now, utilized as office space, and so we want to make sure that this open cubicle layout is properly isolated as well. So in order to understand all this, we probably need to know the basics and know what sound. and how it travels. So we define sound as the wave of motion in the air and other elastic media. And today we're going to be focusing more on what we talk about when we talk about elastic media. So the elastic media in this case will be the walls, the floors, the ceilings of a house or ceiling. And just to provide an illustration on the lack of sound isolation and how it can be annoying, I'll use the example of a typical home theater. So as a reference, Hollywood typically records the quietest passages in a movie on a soundtrack at around 20 dBs, which is the decibels, and the decibel is the expression of sound level, and that's how we measure the different volumes of sound, correct? So 20 dBs is what Hollywood records these quietest passages. Now, typically in your home, you're gonna be looking at 30 dBs of sound. And that's including the different noises like, your different appliances, the fixtures, your air conditioning noise. So right there, you actually see the discrepancies. And I'm sure I'm not alone when we're watching a movie and then we turn it all the way up and then commercials come and then they are actually super high, higher than those quietest passages. Or maybe there's like that small dialogue or just a very quiet scene on a movie. And next thing you know, the volume goes up and then you have to be constantly chasing the volume on your remote control. So that's just an example of, of the different levels of decibels that we're constantly dealing with. And again, this is just a perfect example on a home theater or multi-purpose room. But, just for the sake of it, so what do? We either keep on chasing the volume or we make the room quieter, which sometimes it could be very pricey and expensive, but those are just your two options at that point. So, this is what we keep on calling that the client chasing the volume and turning it up and doing the different scenes. And then, it's obviously a very unhappy and not a very satisfying situation for anybody to go through.
Vanessa, which slide should we be on?
How much isolation is required?
Okay, good. And we're keeping up.
Perfect. So how much isolation do we need? And that depends on the type of noise that we're trying to stop throughout the room and what type of structure we're trying to prevent the sound from passing. The focus needs to be paid in addressing the particular frequencies and the levels of sound. For instance, because not everything fits one size, right? For instance, isolating a room of conversation. So let's say if you have a small office in your house, or maybe you're working with a commercial setting where there's offices and they need to keep privacy, this type of rooms are going to have to require treatments that attenuates the middle frequencies. In isolating a room for music system or a home theater requires certain construction techniques that prevent low frequencies. So right here, we have two different examples of having an office setting or something more personal that is going to be covering the middle frequencies. And again, on a home theater environment, we're more concerned about the low frequencies of the music and how they travel. One thing to realize, and that is important to keep in mind, and just to give you perspective, for instance, speaker manufacturers, they use what they call anechoic chambers. And these rooms are like 0 dB inside. They're about 16 feet thick. And I'm sure, Jeff, I don't know if you have experienced any speaker manufacturer in one of these places is so quiet that you probably will go crazy. And I think the longest somebody has been able to stay in a room like that is like 45 minutes. But these are the typical chambers that are used to test the different volumes. So again, it's just an example of how different frequencies travel. And on a chamber like this, frequencies will not travel. They're going to be reflecting within this very thick walls, so it doesn't go anywhere else. So again, that's one of the things to just keep in mind when we're planning a room, or we're planning to, to understand what they're going to be using that space for. It's like, okay, do you want to keep the private conversations private? So we need to plan ahead to cover those middle frequencies. So is this going to be your home theater room? Okay, so now we have to focus on keeping those low frequencies out of the rest of the house. One thing that we like to keep, and one thing that we say in our industry is like, we need to keep on controlling our client expectations. Because, you know, sometimes they don't think about all these little details. But when it comes to sound isolation, I mean, this is just a great practice for this mantra. Because, you know, that's why, you know, bringing the experts into this can actually lower those expectations, or at least make them realistic. And the, you know, the sounds can come from many different sources, and each type might require a unique approach, like I mentioned before. And then we're going to be discussing the different approaches later on here. I'm going to be switching a slide. You guys see this tree bowl, guys?
We do, yes.
All right. So I'm going to be talking about the 3 different tools that we use for this sound isolation. One of them is mass, absorption, mechanical isolation, or what we call decoupling. And it depends on the different frequencies. So high, middle, and low frequencies, like I mentioned before, react differently to the different sound barriers, like the walls, the floors, the ceilings. The high frequencies, which are kind of like a whistle, or like maybe a baby crying, which is like a very high tone, they typically are mostly reflected back into the room. Some are absorbed by the walls and ceilings, but most likely they're just not going to travel as far. The middle frequencies, which is like conversations like we're having right now, or like a very deep voice, those vibrate through the drywall, and then they cause the sound to travel throughout the studs through the other side of the wall. Low frequencies, which are the trickier ones, they vibrate the entire drywall, the stud, and also the joist structure. And then the sound travels pretty much every way through the frame and is transmitted to the other areas. So if you have a 2-story house, it's going to travel up, it's going to travel left, right, everywhere. But we have the different tools, and then we have different materials for addressing those 3 types of frequencies. So like I mentioned earlier, we have the mass, absorption, and the mechanical isolation. And just to give you perspective again, talking about a home theater design, you're going to hear sometimes the term acoustical treatments, and that's something not to be confused with these 3 tools, because these 3 tools are items that we typically use on pre-construction, so that's why we need to plan ahead. So acoustical treatments are items that we add on to already existing rooms, and it refers to the utilizing different types of materials in the placement and within the room. So it could be like different panels that can actually reflect the sound in different places. So again, just one element not to confuse with those tools that we use for isolation. So acoustical treatments or acoustical panels are completely different than these tools that we're going to be talking about. In like sound isolation, like I mentioned before, it's something that you plan in advance, and it's basically a science. There's different formulas, there are ratings and everything that need to happen in order for them to apply. All right, Jeff, do we have any questions so far, or we're good to go?
We're good to go.
Okay. Moving to the next slide here, and we're going to be talking about one of the tools that we're going to address for isolation, and it's called mass. I hope everybody is looking at this.
Yes, we're good.
Okay, perfect. So in this panel right here, we see different forms of mass that we use to block or to isolate the sound. In this case, we're using the 2 layers of drywall instead of 1, and you see it on the graphic right here. In additional to that, we're gonna sandwich a layer or 2 of the acoustical glue, what we call green glue, or loaded vinyl between those layers of drywall to enhance the acoustical isolation. The glue will act like a mechanical isolator, and the mass loaded will add significant mass and absorption within the wall. So right here, we see that we have the two pieces of the 5/8 of drywall. In between, we have the green glue. And typically, we suggest that to be 52 STC on the rating. And then STC stands for the sound transmission class. If you guys are working with the green housing for the LEED certification, for residential and some commercial applications, they're going to require the STC rating to be 55 or above. And unlike decibels, we're on decibels, which is the levels on how we measure volume, we typically want decibels to be low. On the STC, which is the class or the certification rating, we want them to be higher. So the higher, the better, in order to isolate and to protect and to make sure that the sound doesn't travel as far. So again, we see the two layers of the drywall, the green glue, and then of course we have the stud spacing, and then on the other side we have the 5/8 drywall. So that would help attenuate the middle and high frequencies. So this is not for your low frequencies. This is again for conversation rooms, for office space, for bedrooms. So this is typically the planning for that. Okay. Then the next tool is absorption, and I'm sure you guys are very familiar with this, inserting fiberglass or the rock wool or materials into the wall cavity. And we know that typically this is placed inside the exterior walls for thermal reasons. However, insulation can be placed inside of interior walls as well for sound isolation purposes. Like in my opinion, and a lot of the experts' opinions, every laundry room should have its walls and ceilings insulated so that no one can listen to hours of washer and dryer noise, right? So yeah, that's one of the suggestions in rooms where to apply this type of techniques. It is important to, one thing that we like to remind everybody, that it's important that we use this insulation to match the depth of the wall cavity. So, we've seen on a lot of jobs that people just stuff the insulation tightly into the cavity and they compress it. And by compressing that insulation, it defeats the whole purpose of absorbing the sound qualities. So we want to make sure that the depth of that insulation matches the wall cavity. Let's just don't push it all the way in. And again, this technique or this tool is effective for the middle and high frequencies as well. Then we have the mechanical isolation. And in here, you guys are going to see how we stagger the studs. And, and this is what we actually call decoupling. And the physical direct connection of the drywall on both sides of the wall to the same stud is, it makes the sound travel. So the whole idea of staggering the studs, one on each side of it, is to make sure that they don't touch each other, so we don't have those vibrations of the frequencies touching or traveling through the studs. Additionally, we're also adding on the bottom, if you see the different, the 2x6 bottom plates, and they, again, don't touch the other side. They're only touching that stagger stud, 2x4 stud in there. And that would prevent the sound from flanking, and it will provide a sonic pathway around the decoupling of the opposing layer or of the opposing drywall layer. This is ideal, and this is what we typically use for any room that we want to keep the low frequencies from traveling to the adjacent room. So like if you have a home theater room, a sound room, or maybe a multi-purpose room, this is what the technique that we want to use. So as you see, we have the double layer of drywall, we have the 2x6 bottom plate, and the 2x2 corner studs, and of course we have the staggered 2x4 studs, and in between we have the fiber insulation to make sure that, again, nothing touches, and so we don't have those vibrations traveling through to the next room. next slide is what we suggest, or what actually must be approved by a structural engineer. And this is for, any noise traveling through to any floors above you. So this is what we call isolation clips. And we have the resilient channels, which you see on the right slide. And those effectively absorb any vibration of low frequencies, and they decouple the joists and the studs from the attached drywall. So again, when combined with a double layer of drywall and damping material in all these clips, obviously this floor is extremely heavy. So that's the reason why it has to be approved by a structural engineer. But because it's going to be an extremely heavy ceiling. So, but again, if we have a room, if we have a home theater on the bottom, like on the first floor, and then we have another room, you must have that mechanical isolation with the clips, and definitely with the channel, to make sure that those vibrations don't travel. So those are the three different aspects, that the three different tools: the mass, the mechanical isolation, and the absorption. Those are the three tools that we typically use for those rooms that we're planning, that we are working on the pre-construction level. And that's why those conversations are so important when we talk to our clients, and we're planning each room and asking, okay, so what's going to be the purpose of this room? And if you're working with a green home, make sure that the certifications are properly met as well, especially if you're using the correct STC rating. So that's why, again, it's important that those three tools that are utilized are previously discussed as to, again, what's going to be the utilization of each room that we're planning for. Now, what happens if we have an existing room, something that it's already being built? So this is where, we use the two different methods, what we call the absorption or diffusion. And, like if you have, again, an office or a room that has already been built, we're going to still have some challenges. And I mean, unfortunately, those low frequencies, if we're dealing with a multi-purpose room or like a listening room, they're still going to travel, because these two methods are not going to help completely get rid of them. They're just going to diffuse some of this. So for instance, absorption, you can cut down on the noise level in a room by adding different materials that can absorb the sound waves. What kind of materials? Well, we're talking about carpets, soft furniture, we have drapes, throw pillows, maybe some covers, but those will be the ones that will help absorb. Some people also here add some of the acoustical panels with cloth to absorb some of that, but that'll be one of the methods. The next one will be diffusion, and this is when you have like sound waves that hit large, hard flat surfaces like hardwood floors. They reflect off each other on these surfaces. So it's, like it can give you a perception that the room is actually louder than what it typically is. But by placing items into the room that can break the sound waves into smaller pieces and scatter those waves in different directions, the sound will definitely drop at a different volume level that is no longer problematic. So, some examples of this typical diffusers would be your furniture, bookshelves, paintings, lamps, and seating. And again, here you can add some of the wood panelings that on the acoustical treatments that are sold as well. One of the items that we tend to skip and we forget often are the different recessed lighting, outlets, windows, any holes in your house. They're gonna make sure that the noise travel. Trust me on that. So one of the things that we like to think about is making them watertight. That it doesn't matter where the leak or how small it is, like it's just like water, the water is going to find a way through, right? So same thing for sound. It's not an exception. So small gaps between drywall gaps, holes in the drywall or electrical outlets, air conditioning vents around the door, All of this and more will allow sound to escape from one room and penetrate the other. So there are other areas also that needs to be addressed, like the light fixtures, the docks, the pipes. Those are going to make sure that the sound travels as well. So, like that's when we suggest using the acoustic caulking to reduce the noise transmission. Also, the weather stripping around doorways and windows can improve sound isolation and prevent sound leakage. And also to take measures to prevent switch and outlet covers in HVAC grills, doors, light fixtures, and others from rattling. You can use putty or different type of materials, like for instance, in home theater applications, you're gonna see that a lot of our AV installers, that they actually glue the screws in the air conditioning vents, so that prevents from future rattles, and that could be very annoying. I mean, we actually here in our office at times, like we have one of our light fixtures that when the AC turns on, it just vibrates for a few seconds, and it's one of those things that once you hear it, it's just there, and it's very annoying. Gonna switch my slide here. Okay. And then, there's other areas too, like, like I mentioned, the HVAC system components can potentially create the noise and can be heard through the vents, like that example that I just mentioned. But how can we prevent this, right? So there are inline silencers available, and they're kind of like little tubes that connect to your AC, and they come in 5 inches or 6-inch diameters. Or you can simply lengthen the run of the ductwork from the main unit to a room by using S-turns. And this will help greatly to reduce the different noise level. Also, the grills in a room can whistle if the volume of the air passing through the system is too great. So that's something to work with your HVAC company and make sure that we have the proper amount of AC vents. And there's a formula to that. So, sometimes increasing the amount of vents or making it bigger or just doing different methods can help greatly. But I think, again, this is where the conversation starts, and make sure that everything is planned accordingly. Another thing is like the HVAC ductwork can transfer noise from one room to the other. And having two same areas sharing the same duct can transfer noise from one room to the other. So if you have a private conversation here, most likely you're going to hear it, even if you already isolated your walls. If you're sharing your air conditioning duct, that noise is going to travel through it. So you're going to see that a lot of this is mainly more in commercial applications. You see this in clinics and hospitals often, where if you're going to have the need of a conference room or private space, they actually have a dedicated duct run to the HVAC for this specific room. And then there's also commercially available products that can help dampen the noise as well. Plumbing system is something that typically gets overseen, and it does create the noise and it transfers the noise. And to reduce the plumbing noises, pipes need to be correctly secured to the walls. And we suggest also wrapping the pipes with insulation to reduce the noise. We also want to keep in mind that, yes, we're trying to keep the noise away from these devices, but there's certain devices that need to be heard, like your fire alarms or smoke alarms. So, just keep that in mind, that it's, there's certain things that obviously are safety first, and that they need to be heard when needed. So what's next? So when the job is completed, everybody involved in the project, and that, like the engineers, the architects, builders, the experts on integration and installation, the technology experts here, everybody involved in the project. I'm sure we all want the client to feel that he or she has received the best service from their team. And I think this is best achieved when all the trades, when we all work and we all collaborate and we're brought into the project early. I think that's the key component to everything, that, that we are brought in to the project early, that we communicate often, that we respect each other's strengths, and that we rely on each other's expertise to manage the project, and that each party has an input, and that we meet the expectations, and that we're always clear with our client and set their expectations clear from the beginning. So, but this communication is key, and due to the different advancements in technology today, including how to minimize the impact visually and audibly, it is easy for electronic system professionals to offer and achieve high levels of performance while blending into the space and design and decor. So, all this can be integrated if planned in advance, of course. So, any questions so far, Jeff? We're good?
Yeah, so far so good, Vanessa.
Perfect. All right, so I think we defined the difference, the importance of controlling the sound. We learn about the different frequencies, the high, the middle, and low frequencies, and how much sound isolation is required for the different circumstances, for the different rooms, for the different frequencies. We talked about the 3 different tools, the mask. We talked about within the mask about the green glue and the different certifications and classes within the STCs. We talk about absorption, which is the insulation used between the walls. And also we talked about the mechanical isolation, which is the staggered studs that we use to prevent the low frequencies from travel, the decoupling of the studs. And also we talked about the floors, the reinforced floors, and the clips used to make sure that those low frequencies don't travel to the adjacent or to any floor above or below us, and how the importance of a structural engineer to be involved at that point. And we also defined the roles of each one of these elements. And I think the most important thing is that we outlined the design considerations related to the construction. We talked about how important it is that we all get involved at an early stage, and that we need to keep in mind the different aspects. If it's a pre-construction, what we need to plan for, and if it's a room that already exists, what the options and the at that point the compromises are going to be in a room like that. And I think with this is a wrap. I don't know if you guys have any questions. It's a very interesting presentation when I first studied this, because it's one of those things that we oversee. We've talked about hidden technologies before. We have talked about home theaters, how to design them. We talked about landscape, but we often forget on how important it is, the sound isolation. And one example I can give you personally in working from home in the past few months is like, my husband works from home. We have an 11-year-old taking her Zoom classes, and sometimes all those noises traveling throughout, right? And that's when you realize, wow, like we obviously do not have the proper sound isolation, and all these noises are traveling throughout the house through our AC vents and through our walls. So it's one of those things that you foresee, you don't foresee happening, but that we definitely want to have the conversation. We want to make sure that our clients are happy, and that we bring this up earlier enough to make sure that we plan ahead, and that we know that there's solutions out there. There's endless solutions to address the different issues that that might carry. Thank you, guys. I don't know if I can.
Thank you very much for that, Vanessa. I wanted to show a couple of project photos, different degrees of this. Okay, so this is actually a picture that I took of my own theater when I was constructing it. This is a room within a room, 2x6 staggered studs. So the top cap and the part that attaches to the floor, the base there, are 2x6, and then we have 2x4s. You can sort of see the each one of these various things are staggered. When we put the floor in and the riser in the back, it did not touch the wall, so that the vibrations from the subwoofers would not transmit through the members of the stud cavities and whatnot. They're just decoupled. one of the other issues that we have is rattles within a room, and Vanessa, you talked about that a little bit. I want to reiterate that that's probably the worst situation we get into is people picking these fancy sconces that have glass and other like metal and rattling components when you get a bass frequency. And what a typical AV installer would do would be run a sweep, where they take a sound generator and run it through from the very lowest frequency, somewhere around 20 hertz, something that would like rumble your pant legs, all the way up to the higher frequencies, something in the vocal range, and just kind of sweep through and listen for rattles that happen at one frequency or another. Something might resonate, and it's typically air conditioning vents. So I would recommend linear diffusers for that. You're better off having more linear diffusers so that there's no whooshing sound when it turns on and off. And also think about the heat load in that room when you're doing it, that you'll have a bunch of bodies in there at the same time. Projector noise is another big one, as well as equipment noise. In professional theaters, we don't put the equipment or the source equipment I'm talking about, amplifiers, this and that, nor the projector go in the same room. We would usually shoot it through like a projection booth in an adjacent room. In more modest setups, you can put hush boxes in where all that equipment is in the room, but it's got its own specially ventilated and acoustically isolated cabinet that you'd put it in. So that's kind of one that is medium. You know, I was serious about mine. I wanted to do it right, so we did the room within a room and so on. A lot of times we don't have this flexibility. You're kind of dealing with what you have, but at least you can get rid of the rattles. Because a lot of clients say, look, it's just us in the house. We're not waking up a baby or anything, but we do. As you're playing a movie, you know, you'll hear these sounds that'll come up, and you'll think it's a speaker that blew or something like that, and it's probably something in the room rattling. This is one of our more elaborate ones, and this is kind of a messy photo, but what I wanted to point out here on the front wall, look what we got here. These are cinder blocks. So we actually stacked up cement cinder blocks, and that's what these big Cinema Master speakers, it's the same as our theater here at Boca Theater uses the same speakers, same construction, but these are isolated because they're sitting on their own cement platform, and then they play through acoustically transparent fabric. In here this was a reference room, so it's just like Vanessa was saying, when you're in there, you can hear like your own thoughts, right? You close that room and it's like you almost hear, it's like you got tinnitus or something, because you start hearing your blood vessels in your ears. It's so quiet. But we isolated all of these fixtures in the ceiling and shored those up with this material that's on there, and all the speakers have their own back boxes. That's what you're seeing up here. And so that kind of kept everything all solid, and then we did a stretch fabric right over the top of it that just hid everything. So I'll just kind of go through some of these and point out some of the techniques. There's your linear diffuser, and it's got all that fiberglass around it to keep it from rattling, and you know, there's no resonant cavities in there. This client did not like, I happen to like the look of a diffuser, these wooden looking deals in the back. He covered them with, I just think they're kind of cool looking. It's a geometric shape, but it does diffuse and help sort of treat the sound within the room. So we covered all of that with stretch fabric too. Up here at the top, you can't really see it so much, but that is where the projector enclosure was. It was in its own little, it's kind of part of the soffit with a lift that came down to service it. But that's what kept the projector itself isolated from the room. One thing you got to be careful of with this, I've seen some houses where the air conditioning ducts are dropping right in front of the projector. And that's not good at all, because not only is it putting gunk on the lens, but it can actually condensate. So you have to be very careful, because it's obviously warm and hot kind of touching itself. So you got to make sure that the alignment here, you can see a little bit better here with a projection booth up here, that little rectangle square, that's optical glass that it's shooting through. Now that's a better picture there. So in this case, all the ductwork the big fat ductwork went through these kind of architectural sections, and then the middle one, the lower one there, was the projector.
Jeff, do you
So I
typically,
won't go through all of these.
on your projects,
Hmm?
do you typically assign its own dock to your home theaters, or do you work around with the different?
Do I assign what?
Do you assign a specific dock to that theater? I mean, or do you, like like specifically so it doesn't travel, your noise doesn't travel to any other places in the house?
Oh, I got you. Okay, so we have two techniques. In this particular one, this client's room was a reference room. This is big boy stuff. So he has his own air conditioner for this one room with its own thermostat on off. And there's, the air conditioner was up in the attic far away. We did a muffler inside of an inline muffler so that the air return and supplies were quieted down, right? So that's one way of doing it. If like in my house, I shared an air conditioner, but I had a dedicated run, so that goes right up into the air handler, so it's fine. If you've got a lot of these rooms where they have jumpers that kind of connect airflow from room to room, you have to put mufflers in, or you've got to look at isolating. I've seen some people do, add a second air conditioner just for the room. It depends again on the size of the room. How serious you are about making it a reference room, or just something that doesn't wake up everybody else. So the air conditioner is kind of a big deal, but there's easy ways to get around it. Those mufflers, you have to do it when the ceiling's open, but you put them in, they don't go bad. It's literally like a muffler in a car. It just connects on one end, and it's long. They're like 6 feet long, and then you connect the other end. And once you get them up in the rafter and screw them down, you're good to go. But I've looked inside of them. It's like they've got multiple 90s and a bunch of little holes and stuff, very much like a muffler or catalytic converter kind of looking thing for a car. But so yeah, that's it. I would say the biggest issue we have is rattling light fixtures.
Yep.
Those really are probably the biggest problem that you have. And other people put glass shelves in with little knickknacks, and then one thing leads to another, and pretty soon that room does not sound good anymore. So I don't know if there's any questions there from the group, but I mean, I think there's different phases here. You can take a bedroom and turn it into a reasonable theater, and you don't even have to go through sound isolation. You could just do sound treatment in the room, just the basic reflection, absorption, diffusion to make the sound in that room sound good. And if it leaks into the rest of the house, well, so be it. So that's sort of level one, is make that one room look and sound good. Level two would be isolating, working with what you have, but either doing a room within a room, or taking some of these extra care with the green glue. I've used that. I've heard people say they get better results with the green glue if they use two different thicknesses of drywall, right? So a 3/4 green glue and then 1/2 inch. So it creates a little bit of a impedance mismatch is the technical term for it, but it's kind of like it goes through one layer at a certain frequency because it's thicker, and then it hits that green glue, and then it has to go through another one. So it really helps to do that. And then the third is like that big boy picture I showed you. Now you're building a room from scratch, right?
Mm-hmm.
You're floating the floor, you're separating everything. You're going, that's a year-long project. And that's what building that room took a year, and then finishing it like 6 months. It was, it was a lot of money, but the results were outstanding. We actually engaged Russ Berger from Russ Berger Design Group. He is a kind of a well-known acoustician in the industry. He does a lot of the newsrooms and sports and big coliseums and so on. He came in as a consultant, and that's what we would do if we're in that tier. We would bring someone in a little above our pay grade, and they would architect it, because you're not going to just talk to the AC guy and say, oh, design this. They don't have any experience with this. They give them a plan, and you say, do this, right? That's how that works. And the acousticians, in particular, Russ Berger Design Group, are capable of doing that entire thing. So it's kind of like 3 tiers, depending on what the client wants to do, how much money they've got, how serious they are about it. You know, you could spend 20,000, you could spend, you know, $1 million, right? I mean, there's sky the limit. A couple of questions in here. What rooms do you use green glue again? Offices, and it's really any room that you want sound isolation, keeping noise from the outside coming in or from the inside going out. So when you use the green glue, you're putting in. Go ahead, Vanessa.
I think typically too your middle frequencies. So you know, like if the green glue, I don't think I would suggest. I don't know, Jeff, if you agree, for your low frequency room. So if you have a sound room, I probably would not use it in there. But if you're gonna have an office or, you know, bedrooms, you know, like with you have those middle frequencies, probably the green glue would be more efficient there.
Well, no, that's true. It's what you're treating. I think you have to do them both. If it's a office, you won't need the mechanical isolation for the subwoofer, that kind of a thing, right? But for a media room where you have subwoofers and all frequencies, you mechanically isolate for the low frequency and you check all your rattle points, right? The air conditioning, the lights, and so on. And then the green glue is for your mid ranges. And that's what you would do inside of the room. And that usually, I mean, what you're doing is taking off baseboards, crowns, all that, because the wall is changing thickness and door jambs change. Like, it gets messy, right? That's why that stretch fabric actually is a reasonable solution. You can hide a lot of those problems, or you add a column right at a transition point. So we have pretty good designers that we work with, both on staff and that we work, like Vanessa's and Jason and company, that we consult with to be able to deal with all of those details that kind of crop up when you convert an existing room into something with thicker walls, you know. So that's it. Was there any other questions on that? I think that was the other.
Hey Jeff, this is Jason Sand. I was just going to add that, you know, out of all these tech talks you guys do with all this cool technology, that common theme is that proper planning and getting involved early on. Because as you can see with the presentation, if we have to build out studs and build rooms within rooms, your team needs to be involved early on in that process.
Yeah, that's a real good point, because some of these things aren't even practical to do after the fact. You just got to deal with it, and it's as good as it can get. But they're actually not that expensive. You know, the room in a room thing, if you've got the space, it's just 2x4s put in a different orientation, right? If you knew in advance, you probably would have done it, and it wouldn't really cost that much in terms of money, just more coordination, you know, because it's something different than the normal trades you work with every day.
Right. So something will comment, I laugh every time I see this presentation, is I think it was the second slide, it said indoor shooting range. I was actually involved in a project in Baltimore. A very famous author of government stories was building an indoor shooting range in a condo building. So one, you can imagine the permitting involved, but two, the amount of sound isolation involved for that indoor shooting range.
Wow.
So people do that.
Yeah, I mean, we've been in houses with indoor bowling alleys. That makes some noise too. Yeah, it's a little crazy what people do, but you know, with normal everyday stuff, there's a lot of things you can do for the 80-20 rule, you know, and make it a lot better than it was. You know, even different padding on your, you know, on your carpeting, right? So when you're walking, you hear that upstairs, different padding. I've seen cork floors on second stories. There's been sound isolation that has occurred just from people wanting to walk around the house quietly. I would not recommend injecting that foam in the walls. I've seen some people do that. That's a nightmare.
Yeah.
You'll never run another wire ever, period.
Yeah.
Forget about it, right? It's not happening. And I've seen it blow out outlets. They thought it was so cool. They drill a hole in and blow it, and then the outlets and switches all push out. Stay away. Not a good idea. It seemed like a good idea at the time, but not good in practice.
Right.
So, all right. Well, we're coming up at noon. Any other questions from you guys? Everybody's still muted, so please feel free to unmute and ask. No. Okay, well, I guess we'll wrap it up. Thank you everyone for staying on through the entire presentation.